So we started this yesterday. We didn't get very far. I think we only did one example yesterday, didn't we? Let's redo that example. Is that all right? Just to kind of get us into it. All right, and this particular question says it says reduce to lowest terms is what it says. To lowest terms. All right? So here we go. We said yesterday, can you cancel out the x squared and the x squared here?
No, you can't cancel them out.
You cannot cancel them out. Let me go through the reason again. All right? So for instance, if I had 3 plus 2, this is the same thing we did yesterday. I'm just going to do it again. Okay, 3 plus, I'll change it up a little bit. I'll put a 3 here instead of a 2. All right, if I had this, can I just cancel out the 3's and my answer is 2?
No, you can't. You got to add this up.
That's right. Okay, so I can't do that. All right, so if in this situation, I have to simplify the top and the bottom, right? And so that would be 5 over 3. So that would be the answer to this question right here. Everybody see that? Why can't you just cancel out? What if I did this? What if I did 3 times 2 divided by 3? Why can I cancel them out here, but I can't cancel them out here? Because this one is being multiplied times 2, right? And this one is being added to this. Do you see the difference? Because when we say cancel out, I think teachers sometimes use cancel out too loosely, would be a good way to say it. I'm okay with saying cancel out. I'm not against it, but you got to know why they cancel out, right? Right here, they cancel out because division is the inverse operation, or it's the opposite of doing what? Multiplication, okay? So if these are being multiplied, I can cancel out if I do the opposite of it, right? So what's the opposite of multiplication? Division. So 3 divided by 3 is 1, correct? All right, and what's my answer right here? It's just a 2. I could have gone 3 times 2 is 6. 6 divided by 3 is also 2, right? I could have done that, all right? But it's a lot easier to cancel stuff out. But you got to understand when you can cancel stuff out. You can only cancel if this is being multiplied, all right? You can only divide it if it's being multiplied. Right here, what's that 3 doing to that 2? It's not multiplying, it's doing what? It's doing addition, isn't it? So I can't cancel out the 3's because is division the opposite of adding? No, it's not. All right, so I can't just cancel out the 3's in this situation. So let's go back to this. Can I just cancel out the x squareds here? No, I can't. Why? Because that x squared is doing what to the other stuff? It's being added, right? Can I do something with the 4 and the 2? Can I say 2 divides into that once and it divides? Can I do that? No. Follow my train of thought, okay? I'm trying to lead you somewhere, okay? If this is being added, you can't cancel it out. This is being added, so you can't cancel it out. What's this doing? It's adding, so you can't do what? Cancel it out, all right? I'm trying to lead you somewhere. So you cannot cancel out a 2 with this 2 and this 4. Why? Because it's being added. Because division is not the opposite of addition. You got it? You can only cancel stuff out when you're doing the opposite operation. So what do we do with this? How in the world do we reduce this to lowest terms if we can't cancel stuff out? Subtract? Is that what you said? No. We did this yesterday. Nisia, tell me. I hear you. I'm just waiting for other people to answer correctly. That's right. You factor it out. Okay? Let me just move this stuff out of the way. You factor. Remember I said yesterday, I said, don't forget about that quiz. The reason I went over the quiz yesterday in class is because we are going to do more factoring. That's not the end of the factoring, just because we did a quiz on it. All right, this problem right here is kind of like 2 problems in one. It's 2 factoring problems, but it's only one actual problem. This is example 1, by the way. All right, so we got to factor this. This is a trinomial factoring. So I put parentheses. Let's extend that a little bit. And then what's this down here? I can factor that as well. All right, so let's see what we get when we factor this. Well, what times what is x squared? X and x. Everything's positive, so that makes it super easy, so they're both plus. Now, what do we ask ourselves? What multiplies to be 4 and the same two numbers do what? Add up to be 4. So what are they? 2 and 2. All right? This is also a perfect square. All right, if you take the square root of this, which is 2, then you double it. That's your middle term. That's how you know if it's a perfect square or not. All right, keep going. What about this bottom one right here? Well, I'm going to put an x and an x. They're both positive, so I put both plus. You can't get really much easier trinomial factorings than these two right here, especially this one right here. So what times what is 2? There's only one option. There's 2 and 1, right? And do they add up to be the middle one? Yeah, they do. So I know I factored it. We good with that? Am I done? Do I circle that? Is it reduced? No, I haven't reduced anything. All I've done was factor, right, the top and factor the bottom. But I can now reduce. Remember how we canceled out? That's right. So is there anything that's the same on the top and the bottom? And by the way, what is this parentheses doing to this parentheses? It's, well, yeah, you could say it's squared, but it's multiplied, right? What is this parentheses doing to this parentheses? They're multiplied, right? There's no sign in between here, okay? And don't put an X in here for multiplication. Right, Kyle? Okay. So, what can we do now? Can we cancel in this situation? Yeah, because we're going to cancel out the x plus 2 and the x plus 2. Why can we do that? Because they're being multiplied, right? And you can do the inverse operation, which is division. So I can take this divided by this, and they do, it's not 0. They cancel out. What's anything divided by itself? It's not 0, it's what? It's 1. All right, so this divided by this is 1, 1 times this. What about this? Can I cancel out the x and the x? No, because the x is being added to the 2. You with me? So my answer is just x plus 2 over x plus 1. And you cannot cancel out the x's here because the x is being added. What's that? You don't need it in this situation because it's not being multiplied by anything else, so you don't need it. If you put the parentheses, I wouldn't mark it wrong. You just don't need it. Okay? That would be your answer right there. Good thing we went over this. We went over this yesterday, but
It was just too fast.
was it too fast? Okay. All right. Oh, that's right. The bell rang, didn't it? All right, let's do another example. Oops, there goes my pen. Seems like I do that every day. Example 2. It says the same thing. I'm not going to write it down, but it says reduce to lowest terms. All right, and here we go. There it is. Is it? Of course it is. Example 1 is always the easiest one, isn't it? And it always gets harder, so you know it's going to get harder. All right, so let's take a look. Can I cancel out the x cubes? Looks like I could, right? I got x cubed on the top, x cubed on the bottom. Boom, boom. I just cancel them out, right? No. Why not? Because it's being subtracted, right, in this case. So these are being subtracted. Okay, if they're being added or subtracted, I can't cancel them out because division is not the opposite of subtraction. It's not the opposite of addition. You with me? So I cannot cancel those out. Can I cancel out this 2 with this 8 and put a 4 up there? No, because this is being subtracted from this. I cannot cancel anything out right now. But what can I do? Factor. That's right. What's up with this one? This is not a regular trinomial factoring. We have a special name for it. Do you remember what it's called? Difference of 2 cubes. Difference of 2 cubes. All right? I didn't put that on the quiz, and I should have, but I made the quiz up last year, and I just grabbed it from my files and gave it to you. But I should have put a difference of 2 cubes on the quiz yesterday, or whatever, the other day, because we had gone over it quite a bit, but we're going to do it right here. So do you remember how to factor a difference of 2 cubes? This is that one where it's what? I gave you a little device to remember. Same, opposite, positive. Okay, that's that one. Difference of 2 cubes is the same, opposite, positive one. All right, so let me put a big old fraction bar here. So what do we put? We put a couple parentheses. The second one's going to be a little bit bigger. Why is the second one going to be bigger? You're going to have 3 things in the second one, and you got 2 things in the first one. All right, so I make that one a little bit bigger. Let's just work on the top. We'll deal with the bottom in a second. Let's put the signs in. That's what I always do. First, same, opposite, positive. So look at this sign right here. What's the same sign? Minus. What's the opposite sign? What's the other sign? Plus. Because the other one, the last one's always positive. Remember, it's same, opposite, positive. You with me? Remember what goes here? A and B. So what's my A in this situation? What's being cubed? X. So I put that there. What's the B? What's being cubed to give you an 8? 2, right? 2 cubed. So what goes right here? A 2. Not an 8, but a 2. Because you put what's being cubed here. Make sense? All right. Now, I put something in the first parentheses here, and I put something at the end of the other parentheses. And so I square the A. In this case, my A is a what? X. So it's not 2x. We're squaring. We're not multiplying it by 2. What are we doing? We're squaring it. And then I take the B. In this case, what's our B? It's the 2, right? Or this one right here. And then what do I do with that? Square that. What's 2 squared? Okay? If you want to put the 2 squared in there so you know how you got the 4, go ahead and do that. But that's the 2 squared, right? This is the A squared plus the B squared. Go back to the video and watch it. Now, what goes in the middle? The AB. So in this situation, this is my A, this is my B. What do I get? I get 2x. You can put x2, but that'd be weird. Wouldn't that look weird if you put an x2? So we put the 2 in front. So now it's factored. Now that is factored. We good? Let's take a look at the bottom. How do we factor this thing? Is it a difference of 2 cubes? No. There's nothing being cubed to give you 2, and there's nothing being cubed to give you x squared. So it's not a difference of 2 cubes. What do I always say when we do factoring? Always look for a common factor. Greatest common factor. That's right. There's an x squared in both of these, isn't there? Yeah. So I factor out an x squared, and I figure out what's left over. If I take this and divide it by x squared, so that's what we do when we factor it out. We divide it. So x cubed divided by x squared is x. Put a minus. And then we take this and divide it by x squared. What's 2x squared divided by x squared? It's just a 2. There we go. Everybody good with the factoring? No, it's not it. What's the problem say to do? It says reduce the lowest terms. Okay, so now that's old stuff. That's just factoring. Okay, we did that in section R5, right? We're in R7 now. So they expect you to know how to factor at this point. What's the new stuff? We got to reduce it. Does anything cancel out? The x minus 2. Now, a lot of people say, well, wait a minute, Mr. Hamrick, you're subtracting the 2 from the x. I thought you can't cancel out if it's being subtracted. But that's exactly right. That whole x minus 2 is in parentheses, which means it's being multiplied by the other thing. So this x minus 2 is being multiplied. So can I cancel it out? Yes. Carter?
I was just about to say, couldn't we just factor out the x squared plus 2x plus 4?
Can you? Can you factor that? Well, we'll get to that in a second. Okay, let's cancel this stuff out first. Watch. So that x minus 2 cancels with what? That x minus 2. Let's write down what's left over. And then we're going to look at it again before we circle it and say that that's our answer. It kind of looks, and that is like the 3rd or 4th time just today I've said this, but it kind of looks like the x squareds cancel out. Do they? Can I cancel out the x squareds? No, why not? This x squared is being added to something, so I cannot cancel out the x squareds. Carter brought up a good point. Let's take a look at this. This looks like a trinomial factoring, doesn't it? Yeah. Okay, so let's try to factor it. I say try because guess what? We're not going to be able to, okay? But let's try it. What two numbers multiply to be 4 and the same 2 numbers add up to be a 2? There is nothing. There's nothing, right? Would you agree? So can I factor the top? Is there a greatest common factor? Nope. Is it a regular trinomial factoring? No, I can't factor that. So what do I do?
That's your answer.
Just leave it like that. That's it. That's my answer. All right? So really, the only thing new today that we've done is this. We've just canceled stuff out. That's the only thing we've done today that's new. That's easy, right? That's really not even that new, is it? You did that when you were a little kid, right? Canceling stuff out. Is it? I don't know. You're always worried about problems being too hard. All right? Don't worry about it. Just get them right. Just learn how to do it. Oops. Just learn how to do them. Once you learn how to do them, then they won't be that hard. Here's another one. X squared minus x minus 12. All right, here we go. Can anything cancel out here? No, nothing can cancel out. So what are we going to do? We're going to factor. All right, let's take a look at this. It's not so bad. That one's an easy one. What's in common with both of these? You had something like this on the quiz too, didn't you? All right, so 2's in common. So let's factor out a 2. What are we left with? 4 minus what? X. Now, we're going to do something a little bit later on. It's a little bit tricky. But for right now, let's just do this. Somebody said factor out a negative 2. That actually would work. Okay, I'm not saying it won't, but I think that's going to be too confusing for everybody. All right, so we're just going to do it like this. Then we're going to take a look at it and then figure something out. All right? Let's do the bottom. Will this factor? Is this a trinomial factoring that actually factors? Yeah. If I put the parentheses there, good chance. Yeah, they probably will. So what do we ask ourselves? We ask ourselves, what times what is negative 12? And those same two numbers add up to be negative what? 1, because there's a 1 there. So what do you think? You got 12 and 1. Is there any way we can add those up, positive, negative, to get a negative 1? 12 and 1? No. 6 and 2. What about 6 and 2? Is there any way to get a negative 1 out of a 6 and a 2? No. What's the other option? 3 and 4. Can you use 3 and 4 to get a negative 1? Yeah, as long as what? The 3 is positive and the 4 is negative. Everybody see that? That's what you got to figure out. So x here, x here. I'm going to slap you upside your head if you keep saying this is too hard. Not literally. I'm figuratively. I'll slap you upside the head. All right? So watch. So it's negative 4 and positive 3. You just have to go through the options of 12. There's not that many. There's 1 times 3, there's 2 times 6, there's 3 times 4. What did I say at the beginning? Did I say 1 times 2? Anyway, 1 times 12 is what I meant to say. 2 times 6, 3 times 4. All right? And you just see which one of those adds up to negative 1. You know the 1 and the 12 aren't. The 2 and the 6 aren't. 3 and the 4 have got a chance, right? And so if your answer is negative, the bigger number's got to be negative. So 4 and 3, the bigger number's negative. All right. Now, let's do this. Does anything cancel out here? Is this the same? Is 4 minus x the same as x minus 4? No. Because right here, the x is negative. Right here, the x is positive. Right here, the 4 is positive. Right here, the 4 is negative. So here's what we're going to do. Okay? What we're going to do, let me see. You know what I should have done? I'll tell you what. Instead of going from here, let's do this. Instead of writing it 8 minus 2x, don't we usually have the x first? So why don't we write it like this? Okay? Because once you look at this, you think, oh, that's pretty close, but they really don't cancel each other out. So let's go back and do this. See what I did? I just switched the order. I put negative 2x first and then the positive 8 second. So instead of factoring out just a 2, what do you think we can factor out? A negative 2. All right, this is what Carter said at the beginning. So if I factor out a negative 2, what am I left with? Well, negative 2x divided by negative 2 is just positive x. And then take this 8 and divide it by negative 2. What's 8 divided by negative 2? Negative 4. Now look at it. Now this looks a lot better, doesn't it? Okay, now I can cancel out the x minus 4 and the x minus 4. And so how am I going to write my answer? Just put negative 2 over x plus 3. And that's how you would write your answer. Bianca, what'd you say? It is, yeah. And, I said earlier that probably the further along you go, the harder it gets. This was the tricky part right here, okay, is just to see it like that, all right? But once you realize that, now you can look for it, right? So if you have a homework problem and they don't put it in the right order, okay, they put the number first and the x next or last, switch it around, right? And then, sure, yeah. There are sometimes you have to manipulate things a little bit to make it work for you, all right? As long as you follow the mathematical rules and you don't break any rules, you're good. Did we break any rules here? No, all I did was just switch. Look, 3 plus 4 is the same thing as what? 4 plus 3, agreed? That's all we did right here, right? We just switched them, all right? But now I can factor out the negative 2, which gives me an x minus 4 in here. And now I can cancel it out. How did I know to do that? Well, I didn't really know to do that at the beginning. Well, I kind of did, but, as far as you're concerned, you probably didn't know to do that at the beginning, but then you kind of get stuck and you're like, oh man, there's got to be some way I can do this. So you go back, switch it around, factor out a negative 2, that changes this, and then there we go. All right? Now, hate to say this, but this is the first step in what we're really going to do. And so this is what we're really going to do. All right? Whoa. So watch this. We're going to do a little bit of stuff with fractions. I mentioned this the other day. Listen. Shh. I mentioned this the other day. What's easier for you normally? Is it to multiply fractions or to add fractions? I would say multiply fractions. I think that's a little easier. Okay, why? Because you don't have to find a common what? Denominator. Okay? Would you agree? All right. The hardest part. Yeah, I'm waiting for you. So the hardest part about doing fractions is finding a common denominator. When you multiply, and that's what we're going to do first. Okay. Multiply. Did I spell it right? That looks weird. Yeah. Okay, when you multiply fractions, it's fairly simple. All right? So, for instance, if I had a over b times c over d. All right? What do you do when you multiply fractions? Just multiply what? Straight across. That's right. Just multiply straight across. So what do we get here? This would be what? AC over BD. What if I had something like this? They don't do this in the book, but what if they had something like this? 3 over 4 times 12. Yeah, I'll do it like this. What if... That's right. So now look, instead of going 3 times 12 and 4 times 9, I'll tell you what, let's not make that a 9. Let's just make this a 6. Okay? What if you had this? Everybody watching? If I multiplied them together, I could go 3 times 12 is 36, 4 times 6 is 24, but then what would I have to do? I'd have to reduce it, okay? It's a lot easier if you just reduce it right in here first. So let's look at the 3. Does 3 divide into 4? No, but does 3 divide into 6? Yes, it does. So 3 goes into 3 once. 3 divides into 6, what? Twice. Okay, now we could take the 2 and divide it into 12, but I'm going to do it this way. Does 4 divide into 12? Sure it does. 4 divides into 4 what? Once. And 4 goes into 12 3 times. Does anything else cancel out? Nope. So what do? we do this. We just multiply straight across. So 1 times 3 is 3, over 1 times 2 is 2. Everybody good with that? All right. We're going to do the same kind of thing, except we're going to do it with algebraic expressions. Okay? We will. Okay? So it's not as bad as what you think it's going to be, I promise. So let's do a problem. Let's do example 3. Did I say the other? Oh, the other one was B. I put 3. It was actually A and B. So this one is actually example 3. Sorry about that. And this is 3A. We're going to do 2 of these. So write this down. X squared minus 2x plus 1 over x cubed plus x. Now, we're not just going to simplify this. We're actually going to multiply it by another rational expression. At first, it looks crazy hard, but once you know how to factor and cancel stuff out, it works out kind of nice. I'm going to put a fraction here and a fraction here. So this is what we're leading up to. All that stuff was just introductory to what we're doing right here. This is the meat of this lesson right here. Everybody got it? All right, so what do? Do I start multiplying right now? No, definitely not, okay? So I factor, that's right. I factor this one. So let's factor it. What do you get? What multiplies to be positive 1 and adds up to be negative 2? Right, not almost. Negative 1 and negative 1, right, would add up to be negative 2, correct? So it's going to be x minus 1, x minus 1. Do you agree? They multiply to be positive 1, add up to be negative 2. So that works. Let's do the bottom. How can we factor the bottom? What's in common with both of these? An x. So factor out an x. What are we left with? X squared plus 1. See how easy the factoring is now? Yeah. Aren't you glad you learned factoring in the other lesson? Yeah. Yeah, you'd be lost if you couldn't factor on these problems. There's no way you could do these. What's in common with this? The 4 is in common. So let's factor out a 4. What are we left with here? X squared plus, you see how they rig this thing? You got an x squared plus 1 here. You got an x squared plus 1 here. What do you think we're going to do in the next step? Now watch. Yeah, you're going to cancel them out. That's right. You got an x squared plus 1 on the top that's being multiplied, right? You got an x squared plus 1 on the bottom that's being multiplied. So what are you going to do with them? You're going to cancel them out, right? Well, there's probably more that's going to cancel, so let's keep going. What's this? So trinomial factoring. So what multiplies to be negative 2 and adds up to be a positive 1? That's supposed to be a plus 1. It kind of looks like an H right now, but there should be a little gap there. Put a 1 right there. Okay. What multiplies to be negative 2? There's only 2 choices, basically. 2 times 1, right? Negative 2, positive 1, or positive 2 and negative 1. Which one is it going to be? It's going to be positive 2 and negative 1. Because when you add them up, it's got to be a positive, right? So the bigger number out of the 2 and 1 has got to be positive. All right. Now, this is the fun part. This is the part where you get to cancel stuff out. All right, this is what I like to do. So let's look on top. Is there anything on top that will cancel with something on the bottom? Well, let's take a look at this. You got an x minus 1 on the top. Do I have any x minus 1s on the bottom? I do. So bang, bang. We get rid of those. Anything else? Do I have another x minus 1 on the bottom? Nope. So I keep that 1 there. Do I have a 4 on the bottom? Nope. So I can't cancel out the 4. What else do I have on top? X squared plus 1. We talked about that earlier. Bang, bang. Knock them off, right? It's like a carnival game. You ever do that where you play little pellet guns or whatever? Just knock them off, right? That's what you're doing. So let's see what we get. What's left on top here then? You got an x minus 1 times a 4. But to make it look real nice and pretty, what are we going to put first? Put the 4 first. X minus 1. What's on the bottom? What's left on the bottom? An x and a x plus 2. And that's it. That's all there is to it. It's not bad at all, is it? Right? We went little steps, right? We took little steps, and now we're walking, right? So we started off crawling, took a couple baby steps, right, with the canceling out, and now we're walking. We're full-blown walking now, right, with this. And that's the answer. Let's do one more, and we'll quit. After we do one more. So this is example 3B. Example 3B. This one's a division problem. So let's talk division for a second. So what if I had this? What if I had A over B divided by C over D? Division, I got 8 minutes, so I got to go quick. So let's everybody listen. Everybody paying attention. So we have this divided by this. Most of the time in algebra, we don't do that little division symbol thing right there, okay? We actually do it as fractions. So what's the same thing as dividing? It's multiplying by the reciprocal. That's right. So how would I rewrite this? I'd write A over B times, what's the reciprocal of this? D over C. Everybody with me on that? That's how you multiply. What if I had this? I'm just going to make some numbers up. I don't know if it's going to come out nice and pretty or not, but 5, 6. Okay, here we go. Everybody watching? What if I ask you to figure out what this is right here? 3 halves divided by 5 6. I can't do that in my head, but I can do this. I can go 3 halves times, instead of divide, 6 over 5. You with me? Now, what can we do here with numbers? I can cancel some stuff out, can't I? 2 goes into 6. 2 goes into 2 once. 2 goes into 6 what? 3 times. Does anything else cancel out? No. So what am I left with? 9 over 5. It's a weird looking 5. With me? All right. Now, let's keep going. Let's do one with algebraic expressions. So here we go. X plus 3 over x squared minus 4. And then that bar right there means to divide. And then I've got x squared minus x minus 12. We actually factored that already. And we factored this one down here already. So this should look familiar to you. So really, all we're going to do is this. We're going to take the top one. Instead of dividing by the bottom one, we're going to do what to it? We're going to multiply by the reciprocal. So keep the top the same. Don't change that one. And then we're going to multiply by the reciprocal. So now, what's going to go on top over here? X cubed minus 8. And then on the bottom, x squared minus x minus 12. So now, that's the only difference with division. We just changed division into a multiplication problem. Everybody see that? We've got a few minutes here, so let's do this thing. I'm going to go a little quicker. X squared minus 4. It's a difference of 2 squares, isn't it? So x plus, x minus, 2 and 2. All right. We factored this already today. Do you remember what it is? Same opposite positive, right? Same opposite positive. A and B. So this is x and a 2. This is x squared. This is 2 squared. This is 2x. See how easy that it is now once you learn that? And then right here is a trinomial factoring. We already did this one today. So we've got an x and an x. What do we get? Negative 4 plus 3. Yeah? Now this x plus 3 doesn't have a parentheses, but what is this x plus 3 doing to all this stuff over here? It's multiplying, isn't it? So I'll put a parentheses around it. And now the fun part. Fun part is knocking stuff off, all right? So x plus 3, do I have any down here? Yep, bang. Oh, I thought I changed the color of it. That's okay. So I cancel those out. What else do I have? I got x minus 2. Do I have any x minus 2s down here on the bottom? Yep, I got this one and this one. What about this? Can I factor this anymore? No, we talked about that just a few minutes ago. You can't factor it anymore. So the only thing that you can do Oh, okay. The only thing, I was looking at the answer and then I didn't see, look at it properly. What do we have left on top? We have an x squared plus a 2x plus a 4. And what do we have left on the bottom here? We got an x plus 2, sorry. And then a what? An x minus 4. Anything else? That's it. You can't do anything else with that. All right? Because nothing else cancels because this doesn't factor, right? And that's it. You're done. So here's your homework. Section R7. This is our first homework, so we'll call it A. All right? And it's pages 69 and 70. And we're going to do... It's a lot of problems to do. Anybody got a book? Anybody got a book real quick? Let me see your book real quick. I originally had 5 to 33. That might be a little too much to do. So let me see. Let's see if I can revise it maybe a little bit so you don't have to do quite so much. Seems like a lot to do. 69, 75, 33. Oh, this is going to confuse you so much, but I don't know if this works out exactly to 33, but we're going to do this. Listen, if this is even enough, I don't know. Let's try it. Every other what? Odd. Okay, so you're doing 5. Are you going to do 7? No. What's the next one? 9. Are you going to do 11? No. What's the next one? 13. Then 17. Then 21. Then 25. Okay. Then 29. Oh, it does go to 33. And then 33. So those are the ones you're doing right there. 1, 2, 3, 4, 5, 6, 7, 8. It would have only been 16 anyway. Should I give you all 16? Nobody votes for 16 instead of 8? All right. I'll give you those. So I'll let you do that. Okay? Because they can be a little bit lengthy. All right. So we'll just give you those. Everybody good with that? All right. That's due tomorrow. So have it done for tomorrow, and then we will move on after this. Now, today we did multiplying and dividing fractions. What do you think we're going to do tomorrow? Adding and subtracting, okay? So you'll really enjoy that one.